Good morning, this is your Stat Sensei, Mr. Spensei, and this is a pre-quiz hypothesis test on this particular version for drugs for cheap. So this is going to be the hypothesis test. A growing number of employees are trying to hold down the cost that they pay for medical insurance for their employees. As part of this effort, many medical insurance companies are now requiring clients to use generic brand medicines when filling prescriptions. The consumer group wanted to compare the active ingredients in a named drug and its generic counterpart. 10 pharmacies. All right. So that's going to be important. That sounds like that's going to be a sample size. So it looks like we have an N of 10. In a large city with more than 100 drugstores, okay. This sounds like a population size. That's going to be also important. I'm going to go ahead and highlight both those things in pink so we can see them easily. Were randomly selected with each store filling prescriptions for both. Okay. If they're doing both, that means they're getting measured twice. Because something's being measured twice, this lets me know that, hey, we're working with a paired. All right. A randomly selected pill from each prescription was selected and the amount of active ingredient was measured. Results are shown in the table and are normally distributed. Super important phrase there because that right there is going to be condition number 3. So, what did it ask us to do? It says, well, at a 3% level of significance, does the above data indicate that the name brand has more active ingredients than the generic? So right here we have at the 3%. That sounds like that's my alpha level. So I'm going to go ahead and make a note to myself. Alpha equals 0.03. Now, one thing we know is because they gave us a level of significance and they're looking for evidence. If you're looking, this tells me this is going to be a t-test. Now, the paired test looks exactly like the regular t-test. The regular t-test is x bar minus mu s divided by square root of n, but we're going to be looking for the differences. And essentially, I'm going to subtract all of these. 244 minus 245 is -1. And I can do it by hand, or I can enter both sets of data into the calculator, which is what I did. I put generic brand in L1 and name brand in L2. And I'm going to go blue 1 minus blue 2. And I get their differences. And like I said, hey, this one's -1. Well, this one's +1. And that's what my calculator is showing. All right. So I have my information. Now, in the formula, these are the differences we're looking for. So let's go ahead and do a stat calc, one var stat. My data list that I'm interested in, stat edit, is an L3. I'm interested in these differences. So when I go stat calc, one var stat, I'm going to go blue 3. And my sample mean is -3.3. And my sample standard deviation is 4.7853. Now, one thing that messes people up is the differences. Well, the assumption is that there is no difference. Otherwise, they wouldn't be swapping from name brand to generic. So the assumption is that there is no difference. All right. So the mean, we're going to assume that there's no difference in active ingredient, in the amount of active ingredient, in active ingredient, excuse me. All right. And this is 0 milligrams. All right. This is also milligrams. And for that matter, so is this. And please remember, N is the number of pairs. All right. Yes. In this case, we have 20 data points, but we only have 10 pairs. So that's what my N is. And once again, that information just came straight off the calculator. Well, what type of test is it? It's a one sample T, but it's specifically a paired. So we need to say that it's a one sample paired T test, right? Really important to include the word paired. Well, all hypothesis tests are centered on the population mean. And our population mean here is assumed to be 0 because we're assuming that there's no difference between generic brand and name brand on the amount of active ingredient. Now, our X bar ended up being um, our X bar ended up being negative. All right. And what did we do? We went generic minus name. And we thought this was more. So just pick a number, and this number is supposed to be less. Oh, if that's the case, I need to have a less than symbol because they said the name brand had to be more than the generic. And I just need to make sure that I list the order that I went on in, and I went generic minus name. So I have less than circled. All right. So I can go ahead and plug that information into to my formula where X bar is negative 3.3. There's my population mean of 0. And here's my sample standard deviation of 4.785 and the number of pairs that I have. Our hypothesis. Our hypothesis is always going to be equal. I don't care whenever, for this course, we'll always have an equal sign for our hypothesis, for our null hypothesis. Every single time, the null hypothesis will be equal, be an equal sign. And if we're working with paired, this will always be 0. And I'm going to go ahead and put mg because that was, they said, the amount of active ingredients in milligrams. And our hypothesis is also, our alternative is also milligrams. And it's exactly the same, except for the fact this is a less than, which we came up with over here. And this is again saying it, hey, the generic, pick a number, 40, name brand. We thought the name brand was going to be more, so we made a bigger number. So this looks like gives us the inequality shape. All right, we need to define our parameter, and it's going to be let mu D equal the true population mean of the differences. So this should have a D on it. So let's add that. So let mu D equal the true population mean of the differences in active ingredients and medication, generic minus name brand. All right. Really important that you include the order. And this right here, this phrase, I can't tell you how important it is. Need you to get used to saying mean of the differences. That's for paired. Paired data is mean of the differences. All right. So let's go ahead and run this test. So we go stat, test, and it runs just like a regular one sample t-test. We need to make sure data is highlighted because we put all that data into the calculator. Our mean is 0. And the list that I care about is not L1, it's not L2, it's the differences which we put in L3. I'll go back and show you that. Those were the differences, and that's what we care about. So stat, test, t-test. And to get to L3, we're going to press the blue button followed by the number 3. And we chose a less than because we thought the generic had less than the name brand. And we calculate, and we get a t-statistic of negative 2.1807. So in this case, the probability that t is less than negative 2.1807 is 0.0285. Well, up above, we said our alpha was 0.03. Well, 285 is less than 300. And by the way, make these the same length. If this is 4 decimals, and it should be 4 places, we should have 4 places here. And then it's easy to see that that 285 is less than 0.03. So our decision is to reject the null. Well, we haven't done our conditions. Well, the first condition is the random condition. And sure enough, they said, hey, you know what? They're randomly selected. So we have a random sample of size 10, and that was given. So we can go ahead and check that off. The differences. In this case, our differences are independent, and we need to say that, and we can just make that claim. Differences are independent. Just always make that claim every single time. The next thing, our number of pairs, we had 10. Well, 10 times 10 is 100. And we said that there was at least 100 stores. So we can come back and say, well, N is less than 10% of population. All right. And then the normality condition. It's not normal by central limit theorem because 10 is not bigger than 30, so we can't have that. But it tells us up ahead that the differences are normally distributed. So differences are normally distributed, and that was also given to us. All right, after all of that, we are finally ready to write our conclusion. So our conclusion, all right, which is really a restatement of all the work that we've already done. So we've already said earlier, we said our p-value is 0.025, which is less than our alpha 0.03. And we said that right up here, 0.0285. That came from right there. And then it gives our decision. Oh, we reject the null. Well, guess what? That's what we're going to say next. We reject the null. There's sufficient evidence. So since we're rejecting, there's enough evidence. If we had failed to reject, we would have wrote there is not sufficient evidence to suggest that the true population mean of the differences, I'm going to highlight that, in active ingredients, generic minus name brand is less than 0. Well, part of this came straight from here. The true population mean of the differences in active ingredients, generic minus name brand, that came directly from there. And then finally is less than 0. Well, guess what? This is a restatement of our alternative. All right. This is a restatement of the alternative. I'm going to put HA underneath it because that's what that is. And I'll show you what I mean. Is less than 0. And I'm going to go ahead and put an mg right here for less than 0 milligrams. All right. I appreciate you watching, and I hope this helped. Look forward to seeing you on the next one. Thank you.